Hey everyone, Miss Barber here again for lesson 1.4 in geometry, pairs of angles. Our learning targets for today is being able to identify adjacent, vertical, complementary, and supplementary angles and find measures of these angle pairs. So lots of vocab coming at you to start. So let's go. The first angle pair relationship we're talking about today are called complementary angles. So complementary angles, when we talk about pairs, think about relationships, it's between two things. So complementary angles are two angles whose measure have a sum of 90, meaning that two angles have to add to 90 degrees. So looking here in my pictures on the right, there's two different ways it could be set up. The angles could be right next to each other, like in this example. So angle 1 and angle 2 form a right angle. Remember, that's what that little square in the corner means. But they don't need to be next to each other. They could be any two numbers that add to 90. So for here in this picture, the measure of angle 3 plus the measure of angle 4 equals 90 degrees. So again, complementary means two angles who add to 90. Supplementary angles are two angles who add to 180. So complementary is 90, supplementary is 180. So remember, 180 is a straight line. So here in my examples of angle 5 and angle 6, they form a 180 degree angle or a straight angle. So that's one way for angles to be complementary. Or again, they can just be any two angles. They don't need to be next to each other. So like here, measure of angle 7 plus the measure of angle 8 is 180 degrees. The biggest mistake, or the mistake some people could make, is confusing complementary with supplementary. There's a few ways you could think about it. There's a little saying for complementary angles that it's always right to give a complement. Complement right, 90 degrees. C comes before S in the alphabet, 90 comes before 180. Or I've even seen this little trick where if a C is 90, two C's becomes an S, 90 and 90 is 180. So again, any little trick you want, especially supplementary angles, we're going to be using that a lot going forward in geometry. Our third definition of the day is adjacent angles. So adjacent just means next to. So you might have heard people use that in everyday language about something be adjacent to something else. Just means that they're next to each other. So in geometry, adjacent angles have to share a common side and vertex. They cannot overlap. So here we have lots of examples of adjacent angles. For example, angle 1 and angle 5 are adjacent. They are next to each other. They share this common side and they share that middle vertex. So again, angle 1 and 5 would be examples of being adjacent. At the same time, angle 1 and angle 2 are adjacent. Again, they're right next to each other. They share this common side. So you might be thinking, angle 2, that's also adjacent with something else, and it is. Angle 2 is adjacent to angle 3. And then angle 3, you might have guessed it, is adjacent to angle 4. And then lastly, 4 and 5 are also adjacent. I'm running out of colors, there's so many. So again, right next to each other means adjacent. Vertical angles, our next definition. Vertical angles are non-adjacent angles that are formed by two intersecting lines. I like to think of these as making an X, or sometimes I call these bow tie problems because they form a little bow tie. So looking here on my example, if you were to draw two or highlight over two lines, so I'm going to highlight over these two lines, you may have noticed that two angles ended up across from each other. Here it would be angles 1 and angles 3. So if I kind of outline them, you can see that they form a bow tie. Vertical angles are actually congruent. They're going to be the exact same. So if they don't look the exact same, they're most likely not vertical angles. So I could say angles 1 and angles 3 are congruent, and they're an example of vertical angles. Notice that angle 2, it would be vertical to both 4 and 5. So 2 is not vertical to any angle because 2 is larger. It's formed by these two lines. 5 is not formed by the exact same two lines. So they have to be formed by the same two intersecting lines. They're not going to be adjacent, not next to each other. They're going to be across from each other. And again, they're congruent. Last definition we have for today is linear pairs. Linear, again, you should be thinking root word is line. So linear pairs are two adjacent angles. So here we see the word adjacent again, that form a straight angle. So they have to be adjacent and supplementary, putting two vocab words together. Linear pairs are going to come up a lot. So notice I have a straight line here. I could call that line AB, BC, AC. We know lots of different ways to name lines. And that's formed by these two angles, angles 1 and angles 2. They're adjacent, they're next to each other, they're shared by this common side, they share this common side, and they form a straight angle. So I can say that the measure of angle 1 plus the measure of angle 2 is equal to 180. They are supplementary. And that's going to be important to note. We're going to be using that fact later on. All right, so now let's start with some examples. Example 1 is about complementary and supplementary angles. It wants us, number 1, to find the supplement of angle Z. Well, here's angle Z, and it told me it was 42.1. Supplement and supplementary are the same thing. It means that they have to add to 180. So that means my two angles, I'm going to write angle A and B. I'm just going to use A plus B equals 180. Let angle Z be the same thing as A. So I'm going to call this 42.1 plus B, whatever that is, has to equal 180. So I could just subtract, because again, I'm trying to find B. I could subtract 42.1 from both sides, and that would tell me what angle Z is. And angle Z is going to end up, the supplement of angle Z, so not Z. Z is 42.1, but whatever this mystery angle is that we're trying to find is going to end up being 137.9 degrees. So we can call that 137.9 plus 42.1 angle Z should add to 180. Great way to check your work. See if they add to 180. For number 2, it wants me to find the complement of angle Y. Well, here's angle Y. Again, complementary means my two angles have to add to 90. So I could say again, A plus B has to equal, this time 90. It's complementary. Weirdly, angle Y is not just a number. It's an expression. It has an X in it. That does not mean we're solving for X. So just because there's an X doesn't mean we're solving for it. We're just going to use this expression in the same way we used 42.1. So I'm going to say for A, I'm going to substitute in 8x plus minus 20 for A, plus this angle B that I'm trying to find, that's the complement, equals 90. Just like before, we're going to use subtraction. So I'm going to need to subtract 8x from both sides. And I'm also going to have to add 20, kind of combining a few algebra steps in a row. Sorry, that's a plus. Combining like terms, I can combine 90 and 20, and that'll give me 110. And I'm still subtracting that 8x. Again, I don't know what 8x is, so I can't do anything with it. So the complement of angle Y is just going to be 110 minus 8x. We usually put parentheses around it and write degrees. Again, sometimes students don't like this problem because it's unsatisfying. We didn't find a number for x. But again, all we wanted to know is the two angles that are going to add to 90 to be complementary. If you took our answer of 110 minus 8x and you added it to the angle y, 8x minus 20, you would see indeed they do add to 90. So we did it correctly. So don't be alarmed that you have x in your answer. That's not a big deal. Number 3, an angle measures 12 degrees less than 3 times its supplement. Find the measure of the angle. So looking here, I see some important words. I see the word supplement, so I know these two angles are going to have to add to 180. And then they say an angle measure is 12 degrees less than 3 times its supplement. Well, 3 times would be 3x, and 12 degrees less would be minus 12. So this is the one angle, and then the other angle would just be x, because this is an angle measure. The other one is 3 times minus 12 less than that. And we're trying to find, first, x. So we're going to set these equal to 180, because again, they are supplementary. I have x's on both sides, on the same side of the equation. So I have to combine like terms. X and 3x is 4x. So I get 4x minus 12 equals 180. Adding 12 to both sides, I'm going to get 4x equals 192. So x is going to be 48. So one of my angles is going to be 48. So this first x that we have, this is 48. This is the same as this 48. To find the other angle, the 3x minus 12, I would just have to substitute that 48 in for x. So doing that, 3 times 48 minus 12 is going to give me 132. So my other angle is going to be 132, and the other one is 48. All right, so number 4, we'll try one more together, and then you can try numbers 5 and 6, checking your answer against the key on the school website. Number 4, an angle is its own complement. So again, let's highlight the important word, complement, complementary. 2 angles add to 90. Find the supplement to this angle. Okay. Let's break this down. First, an angle is its own complement. So I have 2 angles, and they're identical. So I'll call them x and x. So x plus x is going to have to equal 90. They're complementary. Meaning 2x, x plus x equals 90. So x is 45. So the angle, my first angle here is 45. Then they say find the measure of its supplement. All right, well, supplement means that they have to add to 180. So one of my angles is 45. I just have to figure out what the other one's going to be to add to 180. Well, so you could set it up like we set up number 1 if you'd like, or you could just go skip ahead and say, well, I know it's going to be 180 minus 45. My other angle has to be what's ever left over, which is 135 degrees. So that is what's supplementary to 45. So again, pause the video, try numbers 5 and 6. Number 5, they're talking about 2 angles that are complementary. So think, what do they have to add to? Number 6, it says the 2 angles are supplementary. So again, what do they have to add to? Moving on to our final examples of the day about vertical angles and linear pairs. So for the first set, it's going to say tell whether angles 7 and 8 in each figure are only adjacent, are adjacent and form a linear pair, or are not adjacent. So remember, adjacent means that they're next to. Looking here at number 7, I would say that they're definitely next to each other. They're not overlapping or anything. They share this common side right here that I'm going to highlight. That's the common side that they share. So I'm going to go ahead and say that they're definitely adjacent. If they're adjacent, they could potentially also be a linear pair. Linear pairs, remember, are adjacent and form a straight line. Well, looking here, this definitely is a straight line. So this is also a linear pair. I'll just abbreviate it as LP, linear pair. All right, number 8. Again, are they adjacent? Are they next to each other? I'd say so. They share this common side right next to each other, so they are adjacent. Do they form a straight line? That sure doesn't look like a straight line to me. There's definitely a bend in this line. So I would say that they're not a linear pair. So all we can say about this one is that they're adjacent. All right, last one for this, number 9, angles 7 and 8. Are they adjacent? Are they right next to each other? They're not adjacent. Notice there's this angle here on the inside that's adjacent to 7 and to 8, but it's preventing 7 and 8 from being next to each other. They don't share a side. I can't highlight any ray that they share. If they're not adjacent, then they definitely can't be a linear pair. Yes, they form a line, but not. There's a third angle here that's helping them form that line or that straight angle. So we can't say that they're a linear pair. So they're just not adjacent. And obviously not a linear pair. Can't be a linear pair if you're not adjacent. All right. Number 10, name a pair of vertical angles. Remember, vertical angles form a bow tie. They have to be across from each other, across an X from intersecting lines. Looking here, I would say 5 and 2 are a vertical angle pair. And remember, vertical angles are congruent, so I can say 5 is congruent to 2. There is another set of vertical angles here, so pause the video, see if you can catch it, and again, always refer back to the key to help you out. Number 11 says a linear pair. Remember, linear pairs have to be adjacent and form a straight line. Right away, I say, well, angle 1 is definitely next to a few angles. It's next to angle 5 and forms a straight line. So angles 1 and 5 are a linear pair. They're not equal. I'll just say angle 1 and angle 5 are a linear pair. There's actually at least 4 more linear pairs. So again, pause the video. Can you spot the other linear pairs? Number 12, an angle adjacent to 4. So let's locate 4 on my picture. Here's angle 4. Adjacent just means next to, so hopefully you recognize 3 is right next to it. So angle 3 is the only one adjacent. Lastly, number 13. Given the measure of angle 2 is 45. So I like to label in my diagram, always helpful. So angle 2 here is 45 degrees. And angle 3 here is 90. So we can either write 90 or remember you can always draw that little box for 90. Find the measure of all other angles. Okay, well let's start with angles 3 and then 4, which is right next to it. Well, if angle 3 is 90, angle 4 is next to it, and they form a linear pair. They're a straight line. We know straight lines are supplementary or 180 degrees. So the measure of angle 3 and 4 would have to equal 180. So angle 3 plus angle 4 would have to equal 180. I know 3 is 90, so I could go ahead and substitute that in. So with some simple subtraction, you should quickly notice, that the measure of angle 4 also has to be 90 degrees. Getting messed up with the writing there, but that's okay. All right. Now, also remember, we have some sets of vertical angles here. We said in number 10 that 5 and 2 are vertical. So if 2 is 45 degrees. 2 is 45 degrees. The vertical angle, angle 5, would also have to be 45 degrees. So we can go and write that. The measure of angle 5 has to be 45 degrees. Can you find the measures of angles 1 and 6? I'll give you a hint. It's very similar to how we found the measure of angle 4. So go ahead, try that, and again, check it with the key. That's it for lesson 1.4. Have a great day, guys.